Morning, everyone. Just coming at you here with 8.3 day 2. This is just going to put together some of the things that we've been working on in Module 8 with the distance between a couple of points and then reviewing slopes of lines, parallel lines, in particular parallel lines today, but eventually we'll get to some perpendicular lines as well in the next day or two. So you'll see at the top just a quick little review for number 1, where it says properties of parallelogram. So we're going to revisit these shapes. And the first thing that you were asked is just, do we remember what these are? So there were two things. Properties of parallelograms. If we look at these quadrilaterals over here, so obviously in our graph, you have two what we call quadrilaterals because they have 4 sides. So as long as something has 4 sides, it's considered a quadrilateral, but we have special quadrilaterals that are parallelograms, rectangles, squares, and rhombuses. Those are the ones that we've dealt with earlier that we're going to revisit. To be a parallelogram specifically, its special properties in order to be a parallelogram is your opposite sides, so the sides directly across from each other, need to be parallel. That's why you see the word parallel and the word parallelogram. And then the opposite sides are, if you kind of remember this little symbol here, that means congruent, which means they have the same length. So what you're doing here in these problems, when I say determine if the following quadrilaterals are parallelograms, what I'm going to have you then do below is determine, is quadrilateral ABCD a parallelogram? And what we just have to show is, are the opposite sides parallel, and are the opposite sides going to be congruent? So when we look at ABCD, let's start with the parallel first. So what we would need to determine is, if we look at opposite sides, make this a little bit smaller here. So let me get some colors up. So side AB would have to be parallel to side DC. So the way we would write that is, and when we label this, AB is a little line segment. That would have to be parallel. There's our parallel symbol to side DC. For this one, there really is no work involved. We can make this statement just by looking at that value. We can do that as long as we have horizontal lines or vertical lines. So when we look at AB and DC, we can say right away that these are parallel, and then that is simply because they are both horizontal. And that's really all the work that we would need to show or say. The other ones require a little bit of work. So now we have to look at, let me do this color. BC would have to be parallel to AB. So that we're going to have to do a little bit of work, but if you kind of understand parallel, we have to have the same slopes. So if I'm going to go from D to A, I would go up 1. Actually, if we kind of look at our x-axis and y-axis here, these are all going by 2s. So before I make that mistake, let's label these. So right here, this point is at 8. This point is up here at 12. So I would go up 2, 4. And then I would go right. It's 1 mark, but we're really going from a -12 to a -10. So the slope of AD is equal to up 4, right 2. If we find the slope of segment BC, we would want to do the exact same thing if they're parallel, and they are. So from C, we go up 1, 2 steps. So that's really 2, 4. And then we would go right 1 tick mark, which is 2. So again, we would go up 4, right 2. So we can then say, I can move this a little bit, that segment DA is congruent to segment CB. The other thing that would have to be true, and this is what the second bullet is for, is our sides have to be congruent. They have to have the same lengths. So AB and DC, again, are the easy ones. So now we're just going to prove, are the opposite sides congruent? From A to B, A is going to be, there's 1, 2, 3 steps away. Keep in mind, each tick mark is 3, though. So AB is 6 units away from, A is 6 units from B. To get from D to C, I start at D, and then I go 2, 4, 6 units away. So AB, so we'll come down here again. That segment is, in fact, what we say congruent. That's our symbol for congruent to DC. And we would say because both are 6 units long. All right, so we know those are congruent. The other one requires a little bit of work, but that's what we've been doing here this week and last week, where if I wanted to figure out what's the distance of a slanted line, now we have to do either the distance formula or the Pythagorean theorem. With these, this is your last homework assignment. I do think the Pythagorean theorem is probably a little bit easier. So if we make a little triangle, so if I go from this point and I move over here, that has a length of 2. And then I have to go up 1, 2 of these, but again, each of them is 2, so this has a length of 4. What I have formed right here is a right triangle. So I can use the Pythagorean theorem to figure out length from C to D. Think about what happens over here at D. To get from D to A, we would go up to 4. So this has a length of 4. And then I would go right 2. We form a right triangle, and we can then figure out this length. So now notice that these two right triangles, how each of them has a side of 2 here and a side of 2 here. The other side is also common, 4 and 4. So if we did the Pythagorean theorem for 1 to get the missing side, that would also then give us the other side. And then we would know for sure that they are congruent, which they're obviously going to be, but we do just want to justify and say what they are. So we will now do that down here. So if I do 2 squared plus 4 squared equals C squared, we would get 4 plus 16 equals C squared, which is 20. Take the square root of both sides, so square root. And what we see is we'll round to that first decimal place. Each of those would have a length of 4.5. So then we would go ahead and say, if we look up at our diagram, segment DA is congruent to segment CB because both, that spells both, are 4.5 units long. So conclusion here is, yes, this is a parallelogram. Their opposite sides are parallel. Sorry, come back up here. I just noticed my little mistake here. Up here we showed that these were parallel because they have the same slopes. So opposite sides are parallel. Here, opposite sides are parallel here. Down here we showed that the opposite sides are congruent as well. So yes, that is a parallelogram. Okay. Same process with E, F, G, and H. So first thing we have to show is, let's do E and H. We don't have horizontal here, so we got to do a little bit more work. So let's do our slopes first. So that's what this one is going to be. So let's find the slope of segment EH. So to go from H to E, understand this is right in the middle. So this is a -7. So I'm going to go up to 2. So to go up from a -2. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I would go right 3. So I went up 9, right 3. That's the slope of H. If we just go up here and then move over 9/3. So now we have to check GH, make sure that's going to be the same because that's its opposite side. I'm sorry, GF. So if we come over here to G, G is down here at a -9. And he is going to go up to this point here. So if we go up from a -9, this would be 0. So we do go up 9. And then that gets us to 13. We'd be right in the middle of the 12 and the 14. And then when I move right, I am moving right 2 units. Well, if opposite sides have to be parallel, And this one we go up 9, right 3, but this one we go up 9, but only right 2. We can see there, these are not parallel. So that one makes it a little bit shorter. It really then saves you a lot of work here going through all of this. We can then say no, and then we can say because opposite side of EH and GF are not parallel. If we had to go down and find our distance, think about what would have happened. We've just formed right triangles here, right? So to figure out this length here, I would have done 9 squared plus 3 squared equals c squared. But to figure out this length here, I would have done 9 squared plus 2 squared equals c squared. So the fact that one is 3 and the other is 2, if we went ahead and solved this using the Pythagorean theorem, since these aren't identical like they were here with 2, 4, 2, 4, we could see that these aren't going to be the same length either. So if you would have done the length first, you would have found that they're not congruent because they have different lengths to their sides. Okay? So that's pretty much it. Just a little review, putting some old stuff together. The idea of parallelogram having sides that are opposite, or opposite sides that are parallel and congruent. And then now just not eyeballing it, but proving that they are both parallel and congruent by using slopes, knowing that if we are parallel, the slopes have to be the same. And to be congruent, we can now do that with either the distance formula or the Pythagorean theorem to make sure that the opposite sides are congruent. And if it satisfies both of them, like ABCD did, you would say, yes, it's a parallelogram. If we are not parallel, our opposite sides are not parallel, and our opposite sides are not congruent, then we would say no. But we just need to make sure that we would have the work and justification there. Okay, so left you a couple to try. Go ahead and knock those out. Shouldn't be too long. Take a picture, send it to me, and we'll see you guys next week.